In this video, we will introduce about the electrical component, inductor. An inductor is a passive two-terminal electrical component, which is capable of storing energy in the form of magnetic energy. An inductor typically consists of a wire wound into a coil, around a core. Let us consider, an AC source is connected to an inductor, through a switch. When the switch is closed, the alternating current flows into the coil, and a changing magnetic field will be generated around the coil. This changing magnetic field or magnetic flux induces an electromotive force, or voltage, across the inductor. This is also called back EMF. This principle is called Faraday's law of induction. According to Lenz's law, the induced voltage, or back EMF, in the circuit, will oppose the change in current that created it. Each turn in the coil has the same voltage induced in it, as of a single wire conductor. So, if a conductor has more number of turns, then for the same amount of alternating current, the magnetic field induces higher voltage in the conductor. Because, the voltage of each turn adds up, which results in higher voltage. The induced voltage across the inductor is directly proportional to the rate of change in current across the inductor. The negative sign indicates the induced voltage opposes the change in current. Here, L is called inductance. Inductance is the tendency of an inductor, such as to oppose a change in the current through it. Inductance is also defined as the ratio between total magnetic flux around the inductor, and the current. The magnetic flux is denoted with phi, and measured in Webers. And the inductance is measured in Henry, H. Let us now derive an equation for inductance, L. Let us assume that, a current, I, is passing through an inductor, having inductance, L, and, n number of turns. Each turn of an inductor will have a magnetic flux, phi. So, the total flux linked with the inductor is the product of number of turns, and magnetic flux. So, the inductance can be written as, let this be equation 1. The magnetic flux, phi, is defined as the product of flux density, B, and the area, A, through which flux passes. Let the equation be 2. The flux density at a point is defined as, the amount of flux passing through a unit area, at right angles to the magnetic field lines. It is denoted with B. Here, H, is the magnetic field strength. Mu0 is the permeability of free space. By substituting the value of B in the equation 2, we get. By substituting the value of phi in the equation 1, we get. Now replace the value of magnetic field strength H, which is the measure of intensity of magnetic field of an inductor, having length L. We get an equation for inductance L as. In this video, we have discussed about an inductor.